There's also very often an observed difference between the prediction and of the performance and the actual energy consumptions of buildings, and this is a major concern. So you can use some techniques to demonstrate and improve the quality of buildings, and this should be practical to be used by industry mainstream. So in this talk, I will show you some of the contribution of Saint-Gobain in this field to develop and demonstrate practical experimental techniques. And one of such method is called the QB method. So I will showcase a few case studies where we implemented the method. So as I said, the performance gap between the design and the as-built energy performance of buildings is considered a significant risk that may compromise the efforts on meeting the carbon reduction targets set by governments in Europe. And previous research showed that energy efficient building can be delivered through the implementation of quality control measures at each stage of the construction process. However, one of the most common factors restricting a wider uptake of such measure is the time required for such testing. That's why we've been working on developing methods which are much more easier to implement. And one of such methods is called the QB method, which is an in-situ dynamic measure method developed to determine the as-built heat transfer coefficient, that is the heat losses due to the fabric, so both transmission and infiltration of dwellings, and the U values of building elements within one night, so less than 24 hours, without occupancy. So the occupants needs to vacate the building. How it works, it's quite simple. We come in the afternoon in the dwelling. We install some sensors, so heat flux sensors, temperature sensors, some heaters, and some control units. And at the sunset, we just have a step heating. So we have a step constant heating for about half the duration of the night. When we switch it off, and then we have a free cooling of the building. So this is schematically shown on the graph on the bottom left-hand side, where you see the temperature going up as an exponential in red and going down with the blue, and the step is the powers we use. And then there are some mathematics involved in modeling to estimate the parameters, so the heat transfer coefficient and the U values. A distinctive advantage of this method is the time required, as I mentioned, less than 24 hours, so within one night, compared to other established methods, which some of them are standardized, which takes up to 3 or 4 weeks. It's quite a much shorter period. And the method was thoroughly tested in the climate chamber at the Sulphur Energy House in UK, and most importantly in the field through a lot of testing we've done in Europe. And I will showcase some of these examples later on in my presentation. So just to give you an overview, so we've been working on this method for quite some time, about 10 years, and the bulk of the testing has been done in UK, France, and also Germany through different collaborations we had. So in this map of Europe, you will see the colors just acknowledge the number of tests we've done. And so we've done over 1,000 different measurements on over 150 different types of buildings. So mostly residential buildings and houses, a bit of multifamily housing and flats. And the bulk of them are masonry, because most of the testing we've done were done in England and United Kingdom. We also had some examples in concrete and wood. And as you see, Sweden, we are in the range of 10 to 100, and this number is growing. And I will show some of the project we had in Sweden. In terms of main collaborations, I cannot mention all of them, but we had a lot in UK with the UK government, so the Department for Business, Energy and Industrial Strategy base, and also some universities, Leeds, Beckett, Salford, Nottingham. In Sweden, so with Stockholmstat, with a project I will show later on, and also with Bebo. We are involved in a project right now looking at new buildings. And also in Germany with the Fraunhofer IBP, and also some collaborative project at the international level with the IEA or the European Commissions. So the first example, I have 4 examples. One of them in UK, 2 in Sweden, and 1 in Norway. So in UK, it was a retrofit. So it was a project funded by UK government to look at the evaluation of different internal wall insulation systems. I know you're not a big fan of this type of system in Sweden, but it's just to showcase the method, not the systems per se. And there was a comparison about different solutions. And for each stage, so for the baseline and each of the retrofit stages, there were some measurements done with QB and also with the standardized method called the heat flow meter method, and it's ISO standard 9869. And on the chart, you can see the red is the ISO, so the reference value, and in blue, the value measured by Cube. And this is average value from different sensors. So I think it's between around 10 to 15 different sensors on different walls. And there's quite a good agreement. And also what should be said also is that the target, so the calculated value based on the nominal values of the lambda and the thickness of the insulation materials, there's quite a good agreement. So no performance gap after the different retrofits. So this was, you can see more. There was a conference held in Göteborg last year, Beyond 2020, with more details about this project. Now we are moving to Sweden in the project we had with Stockholmstad in Stockholmshem. So it was in Stockholm area in Årsta. So there was a big refurbishment within the framework of a European project called Grow Smarter. So this multifamily housing, I think 13 stories building in Årsta in this residential area. You can see the photo on the right. And so we made some measurements before and after. So I'm not showing here, but for the baseline, we also performed some measurements where we compared, we do a cross comparison with the standardized method. There was a very good agreement. So not only for the external walls, but also for the glazings. I'm not showing it here. What I'm showing here is the measurements before and after the retrofit, and a comparison with the target value. So target value was the U value of the external wall of 0.27, and we measure 0.25 plus minus 0.02. So no performance gap. This was aligned with the target, so it was good. This work was presented in different conferences also as well, if you want to know more details. A project which was, let's say, managed on Saint-Gobain side with the contact we had in Malmö in the multi-family housing. There was a renovation of the courtyard facade, which you can see the photograph on the right-hand side of a building from the 30s. There was external wall insulation based on mineral wool and renders. So we came before and after. So for the baseline, one of the, let's say, the insight or the learning we had was that the U value was much higher than what was expected, about 50% more higher than what was expected, with the U value of about 1.9, which is quite high. After the retrofit, there was quite a spread in the values. We monitored different locations, and we also did some thermographic survey, and what we observed is that there was a slight, I mean, you can debate about, but at least there was a difference between what is measured and what was expected due to cold bridges, due to the balconies, and more about the pillar that was used to fix the balconies to the facade. And this was part of the lack of detailing, I would say, and the focus of this renovation was not so much the insulation, that more the aesthetics of the facade. Okay. So that was the last example for the renovation, and then I'm just going to show you 2 examples of new builds of single-family houses we had in Norway, where we perform measurements in Larvik and Stavanger. So you have the photographs. These houses were built within the framework of we had a program called Multi-Comfort Program within Saint-Gobain, so built a few years back, and we came to these buildings and made some measurements, so overnight. And check that the design and as-built measured values were in agreement. So with U values down as low as 0.10 watt per square meter per Kelvin for the external walls. So that was quite nice. Now I'm going to switch more to, it was scientific, technical. Now it's more about, and maybe my colleagues can jump, or we can take questions afterwards. But what are we thinking to do with this method in terms of business value proposition? Well, there are several options. Measurement service for self-testing, if you're a house builder or you're building your own house. The testing could be done by Saint-Gobain, by third-party or certified contractor for handover compliance testing. Second one could be a service consulting, for example, for mapping buildings. If you do renovation, it's very important if to measure before and after, if you want to check decrease in, I mean, actually the energy savings you will have, which depends highly on the baseline. The third one was also to demonstrate the performance of solution that we sell within Saint-Gobain. For example, we have an infill wall called Silent Wall, and this could be linked to that, to have a certified with U-value measurement of this type of offers. And the fourth one, and there are some more, but I'm just only mentioning 4 today, is has to do with certification schemes, either for new builds or for existing buildings with in-use performance. So you have BREEAM, you have LEED, there's byggnads, and some others, I'm sure. So these are the, let's say, 4 main areas. And in terms of market segments, so either, I would say, mainly residential, but it can be done also for non-residential and for existing or for renovation or new build. But if you want to know more, I'm sure Thomas can tell a lot more about that. So the main takeaways I have, and this is my last slide. So what I try to show you today, and that with this method we can deliver rapid, precise, and accurate measurements, so within less than 24 hours, to engage stakeholders and secure a return on investment, especially for renovation or for recovery plan. There's a lot of things ongoing in Europe around that. And for renovation, also show that you can accurately quantify change in thermal transmitters, so the U value or the R value, following the retrofit of external walls. If you'd like to know more, you can either contact me or my colleague Christian, who is based in Stockholm. Thank you very much. Tack.